So let's take some time to look at this idea of rationalising the denominator, which I guess is division of surds. So 4 over the square root of 2. Now let me say, 4 over the square root of 2, as far as I'm concerned, is a perfectly fine answer. People do have an obsession with rationalising the denominator, but unless they ask for it, I'm quite happy to leave it as 4 on the square root of 2, to be honest. But if they did ask us, the idea is to rationalise. In other words, we want to make the bottom something that we can work out. The easiest way of doing it is squaring the bottom, because then we'll get an integer. But of course you can't change the question. Whatever you do the bottom, you've got to do the top. So we multiply top and bottom by root 2, 4 root 2, but over 2, 2's and the 4 cancel, we get 2 root 2. I suppose why we do rationalise the denominator is if we want to compare different terms. Then it is useful if the surd is just in the numerator and not the denominator. 3 over 2 root 5. A lot of people make, well, it's not a mistake, but I can't think of a better word than to say make the mistake of multiplying top and bottom by 2 root 5. I mean, as I say, it's not a mistake. It will come up with the right answer. But you only have to multiply by the surd part. So we really only have to multiply by root 5 on root 5. And we end up with 3 root 5 on 10. Had we multiplied top and bottom by 2 root 5, we would have got 6 root 5 on 20, and then we would have had to do some cancelling. So it still works. It just means you're going to give yourself a little bit more work to do down the track. Okay, 2 terms in the denominator. We multiply by its conjugate. So root 2 plus 1 on root 2 plus 1. And we do that because we know the conjugates create difference of 2 squares. That way we get a whole integer rather than having a surd in the answer. And we want to rationalise the denominator. And so we get 3 root 2 plus 3 on 2 minus 1. In this case, the 2 minus 1 is nice and easy. It's 1, of course, leaving us with an answer of 3 root 2 plus 3. This is a classic sort of one, because we end up, when we multiply the top, we get a perfect square. On the bottom, we get the difference of 2 squares. So 4 plus 4 root 3. By the way, you'll see this a lot in examples where the bottoms work out to be really nice, neat numbers. And both of my examples, of course, they've turned out to be 1. Would be nice if life was always like that, of course. Not always going to be 1. 7 plus 4 root 3. Okay, there we go.